Managing GitHub at scale isn't just about access anymore. It's about automation, governance, and supporting an entire enterprise. In this part, we're moving beyond core administration and focusing on how to support and scale GitHub across large organizations. I'm Michael Michel, and in this session, we will focus on how to operate GitHub at an enterprise level, especially around authentication, automation, support, and user management. We're moving from how GitHub works to how you scale and support it across an entire organization. When organizations scale, you can't manage GitHub manually anymore. You need a platform to do the heavy lifting. To simplify how GitHub Enterprise works, think of everything in two categories: upkeep and automation. Upkeep is everything you configure and control. Authentication like SAML, SSO, security and access policies, integration like GitHub Connect. These are things you set up once and maintain over time. Automation, that's where GitHub really scales. GitHub Actions runs on your build and deployment. Advanced Security scans your code and automatically checks for any issues, any problems with it. And we have Dependabot that keeps your dependencies updated. These run continuously and they run in the background. So imagine onboarding a new team member. That's upkeep. You configure the SSO and access policies. Automation, they securely scan and run the workflows that will automatically scan every document, every commit, so you don't have to manually enforce anything. The goal is simple: configure one, automate everything else. Next, let's take a deeper look on how these features are structured. Let's make this a bit more concrete. So, upkeep is everything you configure up front. These are decisions you make once and then maintain over time. Automation is what happens after that. This runs continuously without you needing to step in. So, upkeep sets the rules, automation enforces them at scale. As your organization grows, inconsistency becomes one of your biggest risks, not really security. If every team works differently, you end up with different branching strategies, different review processes, different level of quality and security, and standards. And standardizing your workflows becomes a little bit harder and more critical. So there are two main models with collaboration models. There's the fork and pull, typically is used for open source or external contributors because you don't want them to edit the main branch. And there is the branching model. This is used internally, where teams work in the same repo. So most enterprises will use a branching model as their default strategy. The branching strategy is pretty much consistent with branching. I know it seems a little bit different here because we talked about collaboration models, we talked about fork and pull, and then we talked about branching, which internal teams. But then we have also the concept of branching conventions and branching strategies within the conventions. Consistency is important here because naming conventions like features, bug fix, hotfix keep the stable main branch, and how we can make changes and how do we control merging. The automation and governance here is a bit easier once you set all those standards. We also have rule sets. These are where GitHub Enterprise really helps. So instead of configuring repo individually and defining each rule sets and applying them across multiple different repositories, multiple different organizations, we can set those rules. So we can require pull request reviews. We can enforce CI checks before merging. We can redirect pushes to main branches. So instead of trusting teams to follow the rules, you enforce them automatically to do that. So for example, in a large enterprise, instead of manually reviewing every repo, you define one rule set and it applies everywhere consistently. So standardizing how team works, then you can use GitHub to enforce it. Without rule sets, every repository becomes a special case, and that doesn't really scale. Rule sets solves one of the biggest problems in large organizations: inconsistency. So instead of configuring each repository individually, you define policies once and apply them across multiple repos. That gives you three big advantages. First, centralization. You manage policies in one place. Second is consistency. Every repo follows the same rules. And third, scale. As your organization scales, your policies scale with it. And more importantly, you're not just defining policies, you're enforcing them. So you can require pull request reviews before merging. You can enforce that as a policy. You can enforce CI checks as code must pass tests. Or you can even block direct pushes to protect branches. So governance isn't guidelines anymore. It's built within or as part of your system. So rule sets are how you move from guidelines to enforcements. One question that comes up a lot is, do I still need branch protection rules if I'm using rule sets? That's like we have the older one, we have the new one. And the short answer is that you should use rule sets as the primary tool going forward. They're more scalable, they are more centralized, and designed for enterprise use. But branch protection still matters in a few cases. Older repositories that already rely on it or on those rules. Specific edge cases where you need repo level customization. So it's not about removing it, it's about gradually transitioning from a branch protection to rule set. The important thing here is to avoid is overlapping policies. So if you're configuring the same rule on both places, you can create conflicts or confusion for teams. For example, if a rule requires PR approval and branch protection has a default rule, developers might not understand which one is enforcing the policy. So lead with rule sets, use branch protection only where needed. When things go wrong in an enterprise, it's not usually about the code. It's about access, identity, and integration. This is where upkeep features come in. These are the controls you set up to keep your organization secure and operational. For example, enterprise support. It gives you direct access to GitHub when issues happen, especially important issues with critical incidents or outages. SAML and SCIM authentication. This is how you centralize identity. So user authenticate through your identity provider and access is managed automatically. We have also GitHub Connect that lets you link your GitHub Enterprise server and your cloud server so you can unify users, repos, and policies across those environments. And we also have the access control for GitHub Pages. This will allow you to host internal documentation securely, only accessible to authorized users. So imagine onboarding contractors. Their identity is managed through SAML, access is automatically assigned, documentation is secured internally, and if something breaks, you escalate to support. All of that is handled through the upkeep features. These are the foundations. Without them, nothing scales securely in your environment. You have to do those so that you will be able to react whenever you need to scale your environment a little bit bigger. Let's see how this works. At the organization, we can enable a lot of the advanced features by going to Settings, and then we go to our Authentication Security. That's where we can require the two-factor authentication. And save. So if upkeep is about control, automation is about scale. These features are what allow GitHub to enforce quality and security automatically, without requiring manual intervention from administrators. We have GitHub Actions. GitHub Actions is your automation engine. Every time someone pushes code, opens a pull request, you can trigger a workflow that builds the application, run tests, deploy code. All is done automatically. We also have GitHub Advanced Security. GitHub Advanced Security continuously scans your code for vulnerabilities, secrets accidentally committed to your repos and to your files, and it surfaces those issues directly in pull requests so developers can fix them immediately. So it's not just an alert, it actually creates a pull request for you to know about it. And finally, Dependabot. This monitors your dependencies and detects vulnerabilities, automatically create pull requests to update them so you're not manually tracking security updates. So imagine developers pushing code. Actions runs automatically to test them for them. Security scans check for vulnerabilities. Dependabot ensures dependencies are safe. All of this happens without any manual review from an admin. So automation ensures consistency, security, and speed at scale. Automation is powerful, but at scale, it also comes with cost and resource management. In enterprise environment, you're not just enabling automation, you're also responsible for monitoring how it's being used. With GitHub Advanced Security, you need to track how much scanning is happening across your organization. If users spike, it could mean increased activities or insufficient workflows or inefficient workflows. This helps you prioritize where security resources should be applied. GitHub Action usage, similarly. You can look at GitHub Action and how much compute resources are they used. They're measured in minutes and storage. Different runners have different costs. Like Linux is baseline, but Windows and Mac OS are more expensive. So running inefficient workflows can easily increase the cost for your organization. So imagine your team running long workflows on Mac OS unnecessarily. This can significantly impact your overall usage and cost. So by monitoring usage, you can optimize the workflows and move it to a cheaper environment. Or you can follow the guidelines toward more efficient setups. Automation should scale, but it should also be optimized. At scale, your pipeline matters just as much as your code. So CI/CD is how you move from writing code to delivering value. And in GitHub Enterprise, this is fully automated. So the 3 stages of flows are build. So your code is built. This means compiled code, creating artifacts like packages or containers. Test, this is the next step where we automate tests to validate the quality, unit tests, integration tests, and even security scans. And finally, code is deployed to staging or production environment, sometimes automatically, sometimes with approval gates. In enterprise environment, this isn't just about speed. It's about consistency and control. Every change goes through the same pipeline. Security checks are enforced automatically. Releases becomes predictable and repeatable. So CI/CD turns your development process into repeatable, automated pipeline. Most teams stop at build and test, but enterprise team goes much further. A complete CI/CD strategy doesn't just automate builds, it covers the entire life cycle of your application. So GitHub Action isn't your only option. You can integrate with tools like Azure Pipelines, Jenkins, or CI/CD platform. This is useful if your organization already has an existing pipeline or hybrid environment in place. Next, releases. GitHub allows you to package versions of your software and automate release creation, ensuring consistency across deployments. Security is built into your pipeline. Dependency scanning, vulnerability checks, compliance validation. So your code is validated before it's ever deployed. Finally, visibility. You can integrate monitoring tools and notification so teams know when build fails, when deployments succeed, when issues occur. This helps team react quickly and maintain reliability. So in a real enterprise pipeline, code is built and tested, security checks are run automatically, a release is created, deployment happens, and teams are notified without manual effort. So a true CI/CD pipeline covers the entire life cycle, not just the build. Getting started with CI/CD in GitHub is actually much simpler than most people expect. At a high level, you just define when something happens and what actions should run. Workflow structure, everything starts with the workflow file. That structure of your workflow, everything is within that file, inside your repository. So it lives under GitHub/workflows. It defines your pipeline, uses YAML format, and it tells GitHub what to do when events happen. You define triggers. They can be push to a branch, they can be pull request, and these will automatically start your pipeline. For credentials, you use GitHub secrets. So those tokens, API keys, and credentials are never exposed. And for production, you can define environments and approval gates, so deployments can require review before going live. Start with a simple workflow, then add complexity. And as you grow, you just can expand that workflow to achieve more and build more tasks into it. As an admin, your job isn't just to set up GitHub. It's to understand how it's being used. So where organizational insight come in, GitHub gives you visibility into how teams are working and where potential issues exist. With activity trends, you can track pull request volumes, issues created and resolved, contribution activities. This helps you identify bottlenecks like slow reviews or growing backlogs. You can also get visibility into teams' activities, which repos are active, which team are contributing, where collaboration is happening or not, where is low engagement on critical repos. These can signal ownership or access issues as well. Dependency risks. So with dependency insight, known vulnerabilities in your library, like license risk, overall security posture, this will give you a clear picture of your supply chain risks. So a repo with a lot of unsolved pull requests, that means there's a review bottleneck. A vulnerability dependency means that there is a security risk. So low team activity can be ownership issues or access problems. So use data to manage your GitHub environment, not guesswork. GitHub alone is powerful, but most enterprises extend it with additional tools. So GitHub Marketplace gives you access to integration, like CI/CD tools, security scanners, and workflow automation. But with that comes responsibility. As an administrator, your job is to control what gets integrated, approve applications at the org or at the repo level, review what permissions those apps are requesting, monitor changes over time, because every integration becomes part of your security model. So there are a few key things to look for when selecting tools. So choose apps from verified creators. Apply a least privilege. Only grant necessary permissions to those apps. Make sure tools align with your enterprise policies. This helps reduce risk while still enabling innovation. For example, a team wants to install a third-party CI tool. Before approving it, you check what access it needs, whether it's trusted, or whether it aligns with your governance tools. So every integration is a security decision. Treat it that way. When you're evaluating tools inside or outside GitHub, you want to focus on a few key characteristics that make them reliable and capable across teams. First, look for tools built on open standards, like YAML workflows or common authentication models. That makes adoption easier across different teams and avoid getting locked into a specific platform. Second, prioritize reusable configuration, like shared variables and templates. This helps you standardize pipelines so every team isn't building things from scratch, which improves consistency across your organization, as well as speed. And finally, flexibility. Your tools should support different environments, cloud, on-premise, or hybrid, and work across multiple languages and frameworks. The goal is to choose tools that adapt to your organization, not tools that force your teams to change how they work. No matter how well your organization is set up, issues will happen. And that's where enterprise support becomes critical. GitHub Enterprise provides different level of support depending on your organizational need and how quickly you need issues resolved. With standard support, you typically get responses during business hours, while premium support offers faster response times and 24/7 coverage for critical issues. As an admin, your role isn't just as important. You need to provide clear, detailed information when opening tickets, including steps to reproduce the issue and relevant logs. This helps support resolve problems faster. Support is a partnership, so clear communication leads to faster resolutions. One of the most important things to understand as an admin is what's your responsibility and what belongs to GitHub support. In enterprise environment, not every issue is yours to fix. Knowing when to act and when to escalate saves time and reduces risk. As an administrator, you handle day-to-day operation, manage repository access, fix permission issues, clean up commits, or restore branches. These are things you can directly do inside GitHub. Support responsibility starts with recovering deleted repositories, handling compromised accounts, resolve billing or back-end system issues. These go beyond what you can manage yourself. Focus on what you can control and escalate what you don't. When working with GitHub support, it's important to understand what type of issues they actually handle. Support isn't their day-to-day admin tasks. It focuses on specific categories where deeper system access or intervention is required. So for account issues, account-related issues that includes things like maybe they lost their 2FA device or can't log into GitHub, support can verify identity and restore access to those. Security incidents. If an account is compromised or there are suspicious changes in a repository, GitHub support can help contain the issue and guide recovery. Abuse cases. This includes violation like inappropriate content or misuse of platform. Support can investigate and take actions when needed. Support focuses on user, security, and platform level issues. Everything else typically stays with the admin. Not all issues are treated the same. How you categorize a ticket directly impacts how fast it gets resolved. When opening a support ticket, your goal is to clearly match the issues to the right priority level based on impact. Low priority is general question or feature requests. Medium cover issues affecting individual users like access, workflow problems. High priority is when a team or service is impacted, like a major workflow failure. At critical, now that critical is reserved for the most serious cases, security breaches, system outages, or anything blocking access entirely. It's important not to overuse high or critical priority. Those should be reserved for issues with real business impact. Set the priority based on the impact, not just urgency. When problem can't be solved through normal troubleshooting, you need deeper visibility on what's happening. That's where Support Bundle comes in. They provide GitHub support with detailed diagnostics, information about your environment. A support bundle typically includes logs, system performance data, and configuration details. All this information is needed so that support understands what's happening behind the scenes. To use Support Bundle, you use it when you have performance issues, when you have performance problems, system errors, or anything that requires deeper investigation beyond what you can see in the typical UI. Support Bundle gives the GitHub a full picture so they can resolve issues faster. When support needs deeper diagnostic, the next step is generating the support bundle. And there's two main ways to generate a support bundle, depending on how you manage your environment. You can use the UI. So in the management console, you simply navigate to support section and generate the bundle directly. This is the easiest and most common. And you can also use the command line, where you SSH into the server and generate the bundle. This is helpful for more advanced or restricted environment. Both methods produce the same result, a compressed file with logs and diagnostics that you can share with GitHub support. Once you've generated a support bundle, the next step is sharing it securely. It has a lot of information about your environment. Because these bundles contain sensitive data, GitHub provides a secure process for uploading them. So you open a support ticket and clearly describe the issue you're facing. This gives GitHub the context of what is going on. Then GitHub will provide you with a secure one-time upload link. This is, in some specific cases, you get that link, and that's really how you transfer the data there. And then you upload. You click on that link and you upload the support bundle directly, or there's no need to send files, email files, or consider less secure channels. So always use the secure upload process and share sensitive diagnostic data securely. In most cases, you'll use this upload link, but sometimes it's not an option. When that happens, you still need to make sure you're sharing support bundles safely and securely. One option is encrypting the file before sending it, using tools like archive encryption, so even if it's intercepted, the data is still protected. Cloud storage, so like OneDrive or similar services, as long as the file is private and access is tightly controlled. And in rare cases, we can use physical media. So you might use something like a USB drive. So no matter the method, always prioritize security. In addition to using secure upload link, there is also a built-in option directly in GitHub. If your environment supports it, you can upload support bundle directly into your GitHub Enterprise interface. This approach allows you to simply select your enterprise, go into setting, and upload the bundle directly in the UI. This provides diagnostics without switching tools. Especially useful when you're already working inside GitHub and when a faster integrated option is available. Use this method to securely upload the data and secure your workflow. Opening a support ticket is just the first step. How you manage it after is just as important. Once a ticket is submitted, GitHub support works with you to diagnose the issues and provide a fix or recommendation. In most cases, once a solution or a workaround is provided, the ticket is marked as resolved or completed. Tickets might also be closed if you falls outside the support scope, or if there's no response after multiple follow-ups, so communication is key. So if your issue isn't resolved, you can reopen the ticket or follow up with additional details. Stay engaged. Support works best when communication is ongoing. As your organization grows, GitHub doesn't just get bigger, it gets more complex. At scale, your focus shifts from managing individual repositories to managing the entire environment. So first, you centralize access using SAML SSO, so authentication and policies are managed through your identity provider. Next, you automate your user lifecycle management, onboarding and offboarding user through identity system instead of manual updates. Monitoring and compliance, so tracking access, permissions, and activities across teams. And finally, you optimize pipelines and workflows to ensure performance and cost efficiency as you grow. Scaling isn't about doing more manually. It's about automating and centralizing control. As your organization scale, manual managing user becomes one of the biggest risks. That's why identity management should be automated and handled through your identity provider, not inside GitHub. With SCIM, when a user is added to your identity, the GitHub account is automatically created and they assign access to it. If the role changes, like move teams or departments, their access is updated automatically without manual intervention. And when a user leaves the organization, their access is immediately removed, reducing the risk of unauthorized access. So identity should be automated. GitHub just reflects what is defined in your identity provider. When automation scales, inefficiency scales with it. So how you use APIs becomes very important. When integrating with GitHub through APIs, the goal is to automate efficiently without overloading the system. The best approach is to use event-driven automation, like webhooks, GitHub Actions, so processes run only when something actually happens. Avoid constantly querying the API for updates. This creates unnecessary load and you can hit the rate limit. And finally, make sure you're capturing logs and monitoring activities so you have visibility. That's very useful for auditing and compliance. Efficient automation is event-driven, not constantly pulling a system. As your organization scales, visibility becomes one of your biggest challenges. You can't manually track every change, so GitHub provides you with audit logs and APIs to help you monitor activity at scale. You can track changes to repository access and settings, understanding who granted or removed permissions, and when did that happen. You also get visibility into user and roles changes, like team membership updates or role assignments. And you can monitor app security, seeing when integrations are installed or permissions are changed. Use audit data to stay ahead when it comes to compliance and security risks. As an organization grows, managing teams across multiple environments can quickly become complex. Enterprise teams currently in preview help solve this by centralizing how teams are created and managed. So instead of creating teams at every organization, you define them at the enterprise level. This ensures consistency across all of your organization, while also giving you better visibility into who has access to what. So a platform team can be created once and then automatically applied across all of those organizations, giving them the permissions they need to do their job. So centralized team gives you this ability to reduce duplication and improve the consistency across your environment. As your organization grows, managing integration becomes just as important as managing users. So Enterprise Apps, which is also in preview, gives you centralized control over applications installed across your entire GitHub organization. Instead of tracking apps in each organization, you can manage them at the enterprise level, giving you a single view of what is installed in your organization or in your entire environment. This helps you ensure apps have the permission they need and they're aligned with your security policy. You also get visibility into which apps are being used and how they're interacting with your repository. So centralized app management is used to reduce risk and improve visibility. You don't have to build every automation of every integration yourself. GitHub Marketplace gives you ready-to-use solutions. Those are tools that you can extend GitHub with. These are some pre-built integration, and they can accelerate your development and improve your workflow. Actions are used inside your workflows. They are automated tasks like build, testing, deployments. They work directly with your repository. While GitHub Apps are more powerful integration, but you interact with them through APIs and webhook. You handle things like issue management, security alerts, or external system integration with that, because you kind of call them outside your environment. So instead of writing your own deployment script, you can use Marketplace Action to handle it automatically. So use Marketplace tools to accelerate workflows and avoid reinventing the wheel. Somebody already created the tool, why not use it? One common question is, when should I use GitHub Actions and when should I use GitHub Apps? Both extend GitHub, but they serve very different purpose depending on what you're trying to build. So use GitHub Actions when you're automating workflows like builds, test, deployment. These runs based on events inside the repository itself. GitHub Apps when you need a deeper integration, like you need to connect to an external system. You might be responding to webhook or managing permissions across repositories. A good way to remember this is Actions run inside your pipelines. Apps runs outside GitHub as a service. Use Actions for automation, use Apps for integration. Now let's take a quick look at how Actions and Apps actually work behind the scene. You don't need to understand all the technical details, but having a mental model helps you choose the right tool. With GitHub Action, everything happens inside GitHub. An event occurs, like a push or pull request, a workflow is triggered, job run on a runner, and results are sent back to GitHub. It's closed, automated, and the loop is done. GitHub App, on the other hand, the flow is external. So GitHub sends a webhook event. This app processes the outside GitHub event. Then it does a callback into GitHub using an API. So it's more flexible, but also more complex to implement. Remember, Actions run workflows inside GitHub. Apps run services outside GitHub. So choose the model based on your logic and what needs to run. With thousands of tools in GitHub Marketplace, finding the right one can be overwhelming. But with a few simple filters, you can quickly narrow down the tools to what actually fits your needs. Start by choosing the type of tool. For example, actions for workflow automation, apps for integration. This instantly reduces that search space into those two categories. Then you can filter like cost, category, use cases. So you're only looking at tools relevant to your project. And for enterprise environment, prioritizing tools that are designed for scale and security. So use filters to find the right tool faster and avoid unnecessary complexity. In large enterprises, managing users individually is harder in GitHub. It doesn't scale well, and it introduces a lot of risks. So Enterprise Managed Users, or EMO, solve this by shifting all the management into your identity provider. With EMO, accounts are owned by the organization, not the individual users. So admins have full control over access and lifecycle. These accounts are connected to your identity provider, which becomes the single source of truth for authentication, roles, and user data. When users are added or updated in your identity provider, their accounts are automatically provisioned. Team memberships and permissions are assigned. Access changes happens without manual updates in GitHub. And when a user leaves, access is immediately removed, reducing risk and eliminating stale accounts. Managing identity in your identity provider, GitHub enforces the access from your identity provider. To really understand enterprise identity, it helps to compare enterprise managed users with standard GitHub account. The main difference comes down to ownership and control. Who manages what account? With enterprise managed users, accounts are owned by the organization. Identity is managed through the identity provider, and access is controlled centrally. And users don't have personal public repository. Everything is governed at the enterprise level. With standard GitHub users, accounts are personal. Users manage their own profiles. They can create public repositories, and access is managed more manually. This gives flexibility, but definitely less centralized control. So in simple terms, EMO is enterprise controlled, while standard users are individually managed. Now let's look at how identity flows between your organization and GitHub. In an enterprise setup, GitHub doesn't manage users directly. Everything is driven by your identity provider. When a user is added to your identity system, they're automatically provisioned in GitHub, and they get the right access. If the role or the group change, the permission is updated automatically. No manual adjustment here. And when a user is removed or deactivated, their access is immediately revoked, including any active sessions. So to ensure the access is always aligned with your organization, you need to use that identity system. Identity changes in one place, and GitHub reflects that automatically. The real power of EMO shows up in everyday scenario, like onboarding, offboarding, and protecting your organizational data. With EMOs, everything is driven by your identity provider, so access is always aligned with your organization. When a new employee joins, their account's created automatically. They're assigned to the right team, and they get access to the right repository from day one. No manual setup is needed. When someone leaves, their identity is removed. Access to GitHub is immediately revoked, and there is no risk or leftover access. EMO also helps prevent accidental IP exposure. Users can't mix personal and work account, and consultants only have access to what is defined through their identity system, reducing the risk of cross-project or external leaks. So access follows identity automatically. It's secure, consistent, and scalable. You just explored EMOs, how they're provisioned and how they enforce SSO, and how you stream onboarding, offboarding, and IP protection. Now let's enforce these concepts with a short knowledge check. What feature can you use to expand the kinds of action that you can automate in response to common GitHub events? GitHub Actions, GitHub Advanced Security, Dependabot. And the answer is GitHub Actions. GitHub support is limited to which of the following issues? Account, security and abuse issues, security server and 2FA issues, account, server and security issues, account, 2FA and security issues. And the answer is A, account, security and abuse issues. Which GitHub priority should you use to report critical system failure? Urgent, high, normal, low? You guessed right, urgent. At enterprise scale, success comes from centralizing control, automating processes, and using data to continuously improve. Thanks for joining us for this session. To continue your learning, watch other videos in the course and explore more on Microsoft Learn at aka.ms/learn.